Okay, so today we're going to be talking about some of the interior angles of a polygon as well as the sum of the exterior angles of a polygon. It says here that the triangle sum theorem states the sum of the interior angles of a triangle is always going to be 180 degrees. So interior sum of a triangle is 180. It says we can use this theorem to investigate the sum of the measures of the interior angles for any polygon. So it doesn't matter how many sides we have, we can use the triangle sum being 180 to help us figure out what its interior angle sum should be. So it says that below we are going to divide each polygon into triangles by drawing all the diagonals from one vertex. So you'll pick one vertex in your figure and draw diagonals to other vertices. So in the first row here, they said you had a quadrilateral and they drew you a sketch of that polygon. Looks like they may have chosen this point as the one vertex that they were going to draw their diagonals from, and they drew a diagonal across the figure going to this vertex. Okay, going towards any other vertex is actually going to be a side, like here or here. So we were only able to draw in one diagonal. Okay, our figure, because it was a quadrilateral, had 4 sides. And then it asks how many triangles, what were the number of triangles that were formed in your picture? Well, when we drew in that diagonal, we were left with one triangle here and a second one here. So we had 2 triangles formed. Step B here says multiply the number of triangles that were formed by 180 degrees to find the sum of the measures for your interior angles for each polygon. So since we had 2 triangles formed, I'm going to multiply my 180 degrees by 2. 180 times 2 is 360. So any quadrilateral, which we know to be 4-sided figures, should have an interior sum of 360 degrees. We should be able to follow this pattern to find the interior sum of angles for all the following figures. All right, so the next picture that we're looking at is a figure that has 5 sides. A figure with 5 sides is called a pentagon. So, according to our steps A, B, and C from up above, we're going to pick one vertex. It looks like they chose this vertex right here, and draw as many diagonals across your figure to another vertex as possible. So we're going to have a diagonal drawn here and a second diagonal drawn here. So this time we're going to have 1, 2, 3 triangles that are formed here. So with our 5-sided figure, we were able to create 3 triangles. Step B says to multiply that number of triangles by 180. 3 times 180 is 540. So our angle sum should be 540 degrees for any 5-sided figure. All right, our next figure has a total of 6 sides. Our 6-sided figures are called hexagons. So I'm going to pick one vertex. Maybe I pick this one here. And I am going to draw a diagonal to each of my vertices across the figure. So I can draw one here. I can draw one straight across to here, and I can draw one down here. So this time it looks like we were able to create 1, 2, 3, 4 triangles. If I multiply the number of triangles, which is 4, by 180, I'll get my interior sum. 4 times 180 is 720. So the interior angle sum for a hexagon should be 720 degrees. All right, my next figure has 7 sides. We call 7-sided figures heptagons. I'm going to pick one vertex in my heptagon, and I'm going to draw as many diagonals as possible. So I'm going to draw one here, one to this vertex, one to this vertex, and one to this vertex. And this time we had a total of 1, 2, 3, 4, 5 triangles. So I'm going to multiply my 5 triangles by the angle sum of a triangle, which is 180, to get my interior angle sum for our 7-sided figures, which is going to be 900 degrees. For our next figure, we have 8 sides. We call 8-sided figures octagons. I'm going to pick one vertex in my octagon and draw as many diagonals as possible. So after drawing in my diagonals, we were able to create 1, 2, 3, 4, 5, 6 triangles. Multiplying those 6 triangles by their interior sum of 180 is going to give us our octagon's interior sum. 6 times 180 would be 1080 for our interior sum. So hopefully, after filling in our chart here, we're able to come up with some sort of rule that we can use no matter how many sides our figure has. The more sides a figure has, the more time-consuming it would be for us to draw in all of these diagonals to create triangles. So if we can come up with a rule that works no matter what, we won't have to keep drawing these pictures. So for a figure within sides, let's compare the columns here, which were the number of sides the figure had, to the second column beside it, the number of triangles that were formed. So when it had 4 sides, we had 2 triangles. When it had 5 sides, we had 3 triangles. When it was 6 sides, 4 triangles, 7 sides, 5 triangles, and 8 sides had 6 triangles. So it would appear that however many sides that a figure has, the number of triangles formed should always be 2 less. That being said, I should then be able to say if the figure has n sides, the number of triangles formed would be n minus 2. And to get from the number of triangles formed column here to our final column, the sum of the measures, what we were doing was multiplying the number of triangles that we had times 180. So the sum of the interior angle measures should be 180 times our number of triangles, which we said would be the rule n minus 2. Okay, with that rule in mind, there are a few examples on the back of this page. So if you will flip it over onto the back, let's apply these rules to find the sum of the measures for interior angles for each of the following polygons. So for a 15-sided figure, our rule should be 180 times the number of sides, which would be 15, minus 2 to get the number of sides of our triangle. So this would be equivalent to 180 times 13, because order of operations tells us we should subtract what's inside of our parentheses first. So I am going to multiply 180 times 13, which would give me an angle sum of 2,340 degrees. For our second example, we should have 180 times our number of sides, which is 20, minus 2, or 180 times 18, And 180 times 18 will give us our interior sum to be 3,240 degrees. All right, so next we have a decagon. A decagon is going to be a figure that has 10 sides. So decagon is a figure that has 10 sides. So we would have 180 times 10 minus 2, or 180 times 8, to give us an interior sum of 1,440 degrees. A dodecagon is going to be a figure that has 12 sides. A figure with 12 sides, interior sum would be found by multiplying 180 times 12 minus 2, or 180 times 10. 180 times 10 gives us an interior sum of 1,800 degrees. All right, so now that we have our rule for finding the interior sum of angles, we are now going to flip over to the next page to look at how we can find exterior sum. So it says the figures shown below, one exterior angle drawn at each vertex of each polygon. They want us to record our findings. So we are going to take our protractors and we are going to measure in degrees each one of the following angles. Now remember, whenever you are measuring with a protractor, you put the T of the protractor right here on the vertex, and you're going to be measuring how many degrees it is from this line back towards your figure. So you're going to take your protractor and you're going to measure each one of these angles. For angle 1, you can put your T here. You're measuring between here and here. And for angle 2, we're measuring between here and here. Again, we're looking for exterior angles. So take your protractor and find the measure of each one of those. So our angle 1 should be approximately 115 degrees. The measure of angle 2 should be approximately 90 degrees. And the measure of angle 3 should be approximately 155 degrees. In the last column here, it says to find the sum of all of these angles' exterior measures. So I would add our 115, 90, and 155. To get our sum to be 360 degrees. All right, we're going to do the same thing for each of the following figures. So you're going to take your protractor and measure the degree of each exterior angle. So for angle 4, I'm measuring between these two lines. For angle 5, I'll be measuring between these two lines. For angle 6, I'll be measuring between these two lines. And for angle 7, I'll be measuring between these two lines. So take a moment with your protractor and find the measure for each one of those angles. So we should have found the measure of angle 4 to be about 110 degrees, the measure of angle 5 to be about 70 degrees, the measure of angle 6 should be about 110 degrees, and the measure of angle 7 should be about 70 degrees. So in the last column, we are to find the sum of all of our exterior angles. So I'm going to add these together, and I'm going to get an exterior sum of 360 degrees. All right, now we need to find the measure of the angles for 8 through 12. Again, we're going to use our protractor to do this, measuring exterior angles, so outside of the figure. So for angle 8, I'm measuring between these two lines. For angle 9, I'll be measuring between these two lines. For angle 10, I'll be measuring between these two lines. And for angle 11, between these two lines. And lastly, angle 12, between these two lines. So the measure of angle 8 should be approximately 105 degrees. The measure of angle 9, approximately 55 degrees. The measure of angle 10, approximately 60 degrees. Measure of angle 11, 90 degrees. Measure of angle 12, 50 degrees. And then we need to find their sum. So I'm going to add all of these values together. And again, our angle sum ends up being 360 degrees. So, did not seem to matter how many sides our figure had, whether we had our triangle with 3 sides in the first figure, a quadrilateral with 4 sides in that second figure, or a pentagon with 5 sides in our third figure. Our exterior sum always came out to be 360 degrees. So no matter how many sides that a figure has, the exterior sum should always measure 360 degrees. With that being said, let's now look at the examples here at the bottom of the page. So it says, for the following regular polygon with the given number of sides, find an interior angle and an exterior angle. So because here it says that it is a regular polygon, regular is going to mean that all of its sides are congruent and therefore all of its angles are congruent. So this means congruent sides and angles. So, for a 30-sided figure, we'll first look for interior angle. Well, the sum of the interior angles, remember, is found by 180 times n minus 2. In this case, n is 30, so 30 minus 2. So I'll have 180 times 30 minus 2, or 180 times 28, which is going to be an angle sum of 5,040 degrees. Now it did say it would like us to find the measure of one interior angle and one exterior angle. Well, because they said it was a regular polygon, meaning that all sides and angles are congruent, I should be able to split this angle sum evenly amongst all of the angles. So I'm just going to split this evenly amongst all 30 angles. and I'll get that each angle must measure 168 degrees. For our exterior angles, we know the sum to always be 360 degrees. So again, if I want to find the measure of just one, since it's a regular polygon, meaning all sides and angles are congruent, I should be able to split it evenly amongst the 30 angles. And 360 divided by 30 gives us a measure of 12 degrees. All right, for number 2, we've got an octagon, which remember is going to be an 8-sided figure. So for my interior angles, I'll have 180 times 8 minus 2 for that angle sum. So really 180 times 6, which is an angle sum of 1080. But if I want to know one angle, I'm going to split that evenly amongst the 8 angles. And I will get that each angle must measure 135 degrees. I'm going to do the same for my exterior angles. Our sum is always 360, and I would need to split that evenly amongst the 8 angles. So when I split that 360 evenly 8 ways, I'm going to get that each one would have to be 45 degrees. For number 3, my interior angles. My sum will be found by multiplying 180 times 12 minus 2. Or 180 times 10. Which will give us an angle sum of 1800 to split evenly 12 ways, which makes each angle 150. For our exterior angles, I'm going to split that exterior sum of 360 evenly 12 ways, which means each exterior angle would have a measure of 30 degrees. All right, then we have our heptagon, which remember is our 7-sided figures. So for my interior angles, I'm going to have 180 times 7 minus 2, or 180 times 5, which is an interior sum of 900 to split evenly amongst the 7 angles. And this would be approximately 128.6 degrees. And then for our exterior angles, we're going to have our sum of 360 split evenly 7 ways, which is going to be making each angle approximately 51.4 degrees. All right, and if you'll flip it over onto the back, we've got 2 more examples. This one says the measure of an interior angle is 140 degrees. They want you to figure out the number of sides this figure must have. Well, remember, we said that to find interior sum, we have 180 times n minus 2. And if we want to find each angle for a regular polygon, we were able to split that evenly amongst however many sides or angles that figure has. And apparently, when using this formula, they came up with 140 degrees for each angle. So all we need to do here is solve for the number of sides. So to get n out of the bottom of our fraction, we would need to multiply both sides by n. So I now would have 180 times n minus 2 is equal to 140n, where I can then distribute 180, and I would have 180n minus 360 is equal to 140n. I would then subtract 180n from both sides, and I would be left with negative 360 is equal to negative 40n. And then when I divide both sides by negative 40, I would be left with n is equal to 9. So the figure had 9 sides. All right, then lastly, this one says the measure of an exterior angle of a regular polygon is 72. So again, to find each exterior angle for a regular polygon, we split our angle sum, which was always 360, evenly amongst the number of sides that our figure had. They did this and came up with the solution of 72 degrees, so I just need to solve for n. Again, to get that out of the bottom of our fraction, we multiply both sides by n, and we're left with 360 is equal to 72n. So we divide both sides by 72, and we get 5. So this figure must have had 5 sides. So, for your assignment, it will mostly be asking you to find angles interior and exterior sum. It says to use this link for concave and convex polygons to come up with your definitions. I know you can't click a link on your paper, but I do have this assignment posted in Schoology where you are welcome to click on the hyperlink on the document there, or like it says in parentheses right here, feel free to just do a Google search for your definitions as well. Also, just a reminder, make sure you have completed the Wednesday and Thursday warm-up questions on your warm-up sheet, and we will check Wednesday through Friday's warm-up questions tomorrow in class.